Today's Daily Dose of Math is about finding the volume of a pyramid. I have drawn the pyramid here. In this case, the base of the pyramid is a triangle, an equilateral triangle with side length 10. That triangle is shaded in this diagram. And the height of the pyramid is 15 centimeters. We are looking for the volume of that pyramid. In order to see what I'm doing a little better, I draw the prism that this pyramid would fit into, and I've done that with the dotted lines here that didn't quite fit onto my chalkboard. And I've separately drawn that triangle at the base of the pyramid here in a two-dimensional drawing, and I've cut that triangle in half because I'm going to have to do that to find the height of the triangle when I find its area. A lot of drawings done, but the drawings really help for us to see what we're doing as we work our way through this problem. In order to find the volume of the pyramid, we want to know the volume of that triangle-based prism that the pyramid would fit into, because the volume of a pyramid has to be the volume of that prism divided by 3. So I want to know the volume of this prism. The volume of the prism is found by getting the area of the base, which is the area of the triangle, the area of this triangle, and multiplying it by the height of the prism, and we know that height is 15. So we need the area of the triangle. The area of the triangle, of course, is base times height over 2, and we know that the base of that triangle is 10 centimeters, but we don't know the height. And that puts us in a position where the first thing we do to find the height of this triangle is Pythagoras' theorem. I'm showing Pythagoras' theorem right here. The h in this case stands for the hypotenuse of the triangle. We have to watch out because in this problem we have 3 different things that are represented by a letter h. I rewrite my Pythagoras theorem so that I'm isolating this leg, which I call a. And I don't want to know what a squared is, I want to know what a is. So I rewrite my Pythagoras theorem like this, and I'm ready to start entering some of the values and simplifying. The hypotenuse of this small triangle is 10. So I have 10 squared. And this base is 5. I have 5 squared. Now I can move up here onto my whiteboard. The height of the triangle is equal to this expression, which simplifies to be the square root of 100 minus 25. Which is the square root of 75. Now, I can simplify this. I can get the decimal value for this from the calculator, but I would have to round, and I want to avoid rounding until I really have to. So I'm just going to use root 75 as the height of the triangle. That height of the triangle is the second use of the letter h in this problem. It's not the same as the hypotenuse of this triangle that we used in Pythagoras' theorem to find the height of the triangle. Now, we always knew that the base of the triangle was 10 centimeters, and we're multiplying it by the height, which is the root 75. And we also have to divide by 2 because of this formula. I'm just going to cancel the 10 and the 2, and I get 5 root 75. And again, I'm going to avoid rounding that. That 5 root 75 is the area of the triangle, which means it goes right here. And has to be multiplied by the third h in the problem, which is the height of the pyramid, the 15 centimeters. Which, when I combine the 5 and the 15, gives me 75 root 75. This 75 root 75 is the volume of the prism. And I need that right here. So my numerator in this volume of the pyramid formula is 75 root 75, and has to be divided by 3 to give the volume of the pyramid. The 75 and the 3 can be simplified to give 25. We have 25 root 75. Now all along, root 75 is equal to 8.66 if I round it. And then when I multiply by 25, I get a final answer of 216.5. And it will be centimeters cubed because it's a volume. Now this is a long process, but each of the steps of the process by itself is not very difficult. The student has to be able to get organized. The drawings definitely help. And do the steps one at a time in order to get the values that you need to solve the entire problem. What's interesting about this is that this relationship between the pyramid and the prism always applies regardless of what type of pyramid you have. If we have a square-based pyramid or a regular pentagon-based pyramid, the volume of that pyramid will always be 1/3 of the volume of the prism that it fits into. That is a very useful relationship in math that helps us to solve geometry problems like this. That is today's Daily Dose of Math. Please like, subscribe, and share.